Hello? Works? Yeah? I'm not texting, these are my notes, so.
Are you bored already?
So hey everyone, we are Team Civo, and we're going to talk about running Kubernetes storage drivers on hyper-converged hardware. It's more of a Q&A session, so we don't have like a presentation. This is just like literally 4 slides. Kai, next. So yeah, I'm Kunal. I work as a development manager at Civo. Joined by me are Dinesh and Dave. You have a mic already?
I have a mic, yeah. So hi, I'm Dinesh. I'm CTO at Civo. Been working with the business for about 4 years and been one of the lead architects of the new platform that we've developed.
And I'm Dave. I'm Dave. I've got a couple of years here at Civo as a research and development engineer. And that's most of what I do is just tinker with things. And
Awesome. So yeah, we are a cloud native service provider, and we're here to share experiences on it. And yeah, can you launch a cluster super fast, very cheap, simplicity, and all these things. But we're here to talk about our experiences. We have Dinesh, who's the CTO. So before we move forward, as I mentioned, this is a Q&A session. So we're going to have more audience participation. And we have some Slido for you. So if you just go to your, go scan this on your phone. In the end, we'll have some swag to give away as well. So pick one person for swag.
As a very brief demo of what we do and what we offer, the last demo actually used Civo. So where the cluster was launched and everything, which is nice to see it live. Actually working for once.
So if you scan this, you would be able to see this poll. So you can we're just trying to get some. This is, by the way, completely anonymous. No sign up needed or anything. So it's completely anonymous.
those no people are lucky people. No state, really?
I guess one of the questions for those that have got a no is why are you here?
All right, we can go to the next one, Kai.
When you say stateful data, do you actually mean stateful workloads or stateful apps? Like, what is stateful data?
I mean, that's a Q&A starting already. So in my mind, stateful data is what we're talking about here. So if your pod or container shut down and started off on another node somewhere, the data is persisted within that. And it's not something that's loaded from another pod for something like a cluster and it gets replicated or something, but the volume that's written to disk is available locally on that. So think of like a MySQL database that you're only running one replica of, and you need that data persisted across reboots. Why you're running with one replica of MySQL in the cloud, I don't know.
I've never seen the term stateful data being used. You always talk about either stateful workloads or you talk about data-rich apps.
Yeah.
Stateful data is a new thing. That's why I was curious. Anyway, that's
Run.
Thank you.
All right, this is the next question. How does stateful data on Kubernetes make you feel? So if you just put your,
I'm loving the drunk.
So you can just put your sentences in something and it will populate it. Thirsty for beer. Very mixed feelings.
Hungry is an interesting option.
By mixed feelings, it's either absolutely happy with it or terrified. There's no real middle ground, is it?
Happy, confused, annoyed. All right, one more person typing, then you can move forward. All right, next one, Kai. Why does storage scare you? That's another good one. Quite a lot of folks typing. Cost?
It's evil. That's a pretty good one.
It doesn't? Good one. Cost?
I guess it doesn't people are the same people who said that data makes them happy. Or stateful
All right, cool. We can, two more folks typing in. All right, okay, we can go to the presentation. And this is another one. This is fine, yeah. Cool, so it's a Q&A session. We can just start with might be a feeling that stateful data can't run on K8s. So what are your thoughts on that when we're working with, let's say, thousands of customers? And yeah.
I think it's something we've heard a lot. I mean, even from the Slido cloud there as well, it's a lot of fear about running persistent data, stateful workloads on Kubernetes. And I think it's related to the fact that you're trusting a cloud provider generally to keep your data safe and to move it around pods that are starting up and shutting down quite frequently. And we all know if you've been running data workloads like databases and things like that for a long time, restarts are what really scare you. And seeing that happen a lot on a Kubernetes cluster is probably what drives that fear. But it's something that we can definitely work around, and I think it's moving that data management out to the application layer rather than relying on someone like a hardware provider or a cloud provider to do that for you.
Cool. And yeah, as I mentioned in the start, it's a Q&A session. So if you have any questions to drive the engagement, go ahead. There are a lot of polls, a lot of thoughts. So if you have any questions around that. Anyone? No questions? And yet? Yeah, go ahead.
Yeah, so your title slide said this was an HCI environment. Can you kind of describe what you mean by that and why would I choose that for Kubernetes?
Yeah, we've actually built our entire platform around the hyper-converged idea. Our cloud provider is built from essentially large Kubernetes clusters that are using a replicated CSI to have those local copies on each one of the host machines. And it's proven to be a great way to actually manage a cloud, especially with disparate workloads. Everything's simply a PVC, and if you have replication already there, we get to simply ride on that, and makes migration between hosts a lot simpler.
I think one of the things about storage as well is that latency is a real worry with things like moving stuff over to iSCSI or something like that and having a centralized SAN. So Hyper-Converged allows us to move that workload local, or move the data local to the workload and give that real performance in a cloud environment.
Does that answer your question?
Yeah, it does. So I'll think of how to phrase this better. Go ahead.
I think one of the other benefits we've had from Hyper-Converged as well is we've actually built all of our data centers to be completely remote, and we never have to go to them. So I think we've got 3 sites at the moment. David's visited 1. I don't think I've visited any of them at all, but we rely on that hyper-converged infrastructure to mean that we can offload a lot of that management to remote hands, so that if something goes wrong, we ship out a new compute node, and remote hands just turn it off, plug in the new one, and turn it back on again, and then we provision it there. So it's a lot of thought has gone into, when we're storing data on this, how we ensure we manage failure well. And building from the ground up to have that failure be an option rather than that failure not an option. It's always there and always present with what we do. So building it in from the ground up is really, really key. I think it's something that Kubernetes does really well as well, kind of with containers and pods that are starting and stopping very regularly. When you design applications and deploy applications, you're designing them to turn on very, very quickly, get any state that they need to have, if that's a cache for sessions or like data under the hood, and get that running. And we design for that at an application level with Kubernetes.
Yeah, there was one question they were asking about stateful data. So we can share how we use it with Kubernetes at Civo.
So what we do at Civo obviously is we've got VMs, your traditional compute VMs that we run, and that's sort of completely backed by stateful kind of data, because you've got the underlying OS, and then as customers come on board and they change that, that needs to be there when a VM restarts. So what we do with Kubernetes is we store all of that data as a PVC, and it's a kind of a storage class that we define things like replication and availability, whether that is local to the HCI node or can be remote, depending on what customers are running. So if you're running an Elasticsearch database, for example, you make sure that you're already clustered and that you will have only one replica that's local to your container that's running that. And you're relying on the fact that when it all restarts is that generally state will get shifted by Elasticsearch and moving that to the application layer. So you're making sure that on restarts and DR, you've got a policy there. But then when you're running 99% of the time, you've got really good latency and good storage performance.
If I understood you correctly, you're running your own data center, right?
Yeah.
So what happens with the other stacks, like networking, everything else, and also how does it integrate with the cloud providers?
So we run all of that ourselves. So we run the edge network, we run routers, we own those, and then we've got kind of top of rack and spine switches, and we've designed the stack to integrate with everything. One of the interesting projects we're looking at is whether or not you can run Kubernetes on switches, as in like top of rack switches, and start pushing config in etcd. Then the switch picks it up and just configures ports as servers come up and down, which is really, really interesting. I think, David, there's some talk about running it on the NICs themselves as well, isn't it?
Yeah, that's been an interesting thought that we've been having lately is using these, I forget what they're called, data processing units, DPUs that have been coming out from Mellanox and Intel, where you have essentially a high-performance ARM SoC with 32 or 64 gigs of RAM and SSD storage local to the NIC. And we're looking at potentially putting storage controllers and Kubernetes resources on there to manage the cluster, so we have more resources in the cluster to actually provision for customer workloads.
Yep. Thanks for the question. I have one for like everyone. Can you show a raise of hands who work with data on Kubernetes? Okay, 2 people. Working with data on Kubernetes. So my question around you is, have you had any problems when you work with storage? Like, do you have any stories to share? Anyone? Yeah? Any problems with storage?
Mine is a weird use case because I'm trying to do air-gapped Kubernetes.
We like weird use cases.
You know, it's not something where I can easily just easily shove it into the cloud. I've got a 3U, 4U rack space that I'm limited to use, so I'm having to cram NVMe drives into that rack and do a what is it, a PCIe split out for some on cluster. But the biggest issue right now is we were just going with straight NFS. Now we're migrating to Longhorn, thankfully, fingers crossed. But I guess those are my storage woes.
I think that's really interesting, something we've had a parallel with as well. So we're not quite air-gapped, but because we run everything ourselves, we've got to think of those considerations. We can't kind of offload it to a cloud provider to just give us a disk. So we're using Firestore at the moment to solve a very, very similar problem, which is a CNCF project, or about to be a CNCF project. So it's all open source and allows you to do that. Actually, one of the things we've done as well is we've defined everything via a storage class as well, which means that we can swap vendors and we can kind of plug storage in and out of our cluster quite quickly. And it's something that Kubernetes is really neat that allows you to do that.
Yeah, we've kind of taken to limiting ourselves with the way we interact with our own superclusters to being limited to only through the Kube API through custom resources or normal PVC provisioning processes. So we actually had to migrate between storage vendors from Storage OS to Maya Data. And for that process, we essentially were cloning PVCs and then replacing them in the specs. And that was the entire migration of the workload for an entire cloud, 3 regions, and it was mostly automated. So that's something that's really stuck out was just the fact that if you code around using Kubernetes to manage your storage, the storage part stops mattering. As long as it's working, you can just use it, and if you need to swap it out, you're just talking to Kubernetes in the end.
Speaking of which, was there like any, for folks who may be wondering, any customer impact when you're doing data migration?
There was a few minutes for each one of the virtual machines to actually be shut down, cloned, and booted, but we staggered it so that no cluster would go fully down, and pretty much minimal impact, about 5 minutes per customer, so it worked out pretty well.
Cool. Thank you for sharing your story. Anyone else? Yep.
Just from the perspective of kind of a Kubernetes customer, the biggest issue I see with persistent volume claims is when you try and restart a pod and you get stuck with the volumes exclusively attached to a different node.
Multi-attach errors.
So I try to figure it out. Have you guys done any work on trying to mitigate that or work around it?
A lot of those can be caused by actually what's going on inside the container. When you kill a pod, you're not necessarily issuing like the equivalent to a Linux kill-9 where it is die now. You're issuing a terminate. So it's going to terminate those processes as if it were a normal service. If you take a little bit of time to research how to send signals to Linux processes on pod termination, you can actually gain a little bit more control over there, so you can have a dead process that is marked dead and then it moves on and detaches. A lot of those multi-attach errors are because the other side isn't letting go or hasn't notified the Linux kernel at the very bottom of the OS that it has let go.
In terms of once the pod's dropped off entirely and it's the CSI driver's problem, I tend to notice it just kind of sits there for a while.
And that is going to be dependent on the CSI in a lot of cases, because that's really all the CSI is doing is has an interface that lets Kubernetes ask in a standardized way for a volume and a way to propagate back, yes, I've given you the volume. Everything past that is more or less up to the CSI. As long as it implements that interface, it's fair game. So there might be something in there that needs to be fixed too.
If you're looking to speed that up, though, there are these objects called volume attachments inside the cluster, and you can normally find one and like delete that object, and that triggers the CSI to then go and talk to the node to do the unmount and the detach if it's still around. And that's what Kubernetes is using to track those multi-attach errors. So if there is a volume attachment object, delete it, delete your pod, and it will trigger a retry of that. But what David was saying as well, there is new specs. I can't remember what the YAML is, but when you terminate a pod, either the cloud provider is doing that or you're doing that with a drain, you can run commands on termination to stop using the data and put it into a safe way that the underlying volume can be unmounted.
Cool. Thank you for sharing. And anyone else? Yep.
Is there a limit to the size of the VPC that you can create? Can you go to 10 terabytes?
So the question was, is there a limit to the size of the PVC? Sorry, just repeating for the people at home.
Mike? Yeah. You can.
Yeah, David?
As far as that goes, that's really just a limit of essentially the hardware and the operating system configurations that you have set up. If you have a 2 terabyte disk, you could use that. If you have a series of 12 terabyte hard drives and you have a CSI that can span them into one volume, you could provision that as well. There's not really an internal limit in Kubernetes. It doesn't really care one way or another how big it is.
At the end of the day, you're still getting down to a Linux volume, right? So if you're running on Windows, I think there's still like a 16 terabyte limit. If you're running on Linux, that goes higher. But then it still depends on, are you presenting a block device or are you presenting a file system up to your container? And it's the limits that are presented there. As well as most cloud providers will be looking at their failure domain on limiting the size of a volume that would be created. So in our example, when we're running Hyper-Converged, we have a limited number of NVMEs on each compute node. And that limits the size of a volume that we can provision.
Amazing. Thank you for the question. Anyone else? Yeah.
Can we provide OpenShift? So with us, the way it would go about, we offer compute services, so just bog standard VMs, but then you'd have to provision kind of OpenShift on top of that. So working with, yeah, yeah.
Cool. Do we have any problems to share?
What were we working on the other day? Depends on how technical everyone is, but we were looking probably like 2 days on mknod, which is a very root kernel command of making root devices on a Linux box, and it was kind of just a reminder that every day when you're looking at Kubernetes and you're looking at cloud providers and you're looking at containers, it all boils down to stuff that's been around for a long time, which is it's Linux, it's syscalls, it's block devices, and it was just a real deep reminder that while you can get lost in all of this complexity, it boils down to some really old C code.
Mm-hmm. Yeah, that was an interesting experience, really.
Yeah.
Opening up the man2 page to look at the C function references for make nod. That was a good day.
But outside of that, I think we have had problems. I'm not going to stand up here and say that we've had completely flawless performance and 100% uptime since we went live. But a lot of the problems come down to, rather than like storage, it's on the control plane and getting the control plane to function quickly. So if you're in a position where you suddenly find 1,000 VMs have restarted and you've got 1,000 volumes that now need to get attached across the cluster, you're kind of going with those problems with multi-attach errors, and you're waiting for the CSI to go through a big list of things to do to get that running. So there's a lot of concurrency problems to face when you run at huge scale.
Yeah.
Is the CSI that you guys use, is that a home-built CSI, or is that an off-the-shelf like open source CSI?
It's an open source CSI from Maya Data. It's called Maya Store, STOR. Okay. It's a really nice hyper-converged solution. Very performant as well.
Does it support volume snapshot?
Does not yet. That is something we've been pestering them about, and they've been coding quickly behind the scenes. So that should be something they'll have soonish, I would say. But yeah,
I think that touches on something that's really, really key when you're looking at storage solutions out there. Is one thing we've focused on is finding a partner to work with for our underlying CSI and our underlying provisioning, because finding someone that is there to help you when things go wrong is really, really important, and you're not going to just shout and go into either an abyss of a Slack channel that no one's ever going to read, or into a really complex support tiering process where you get into a first-line person. It's like, yes, no, I really have turned it off and on again. I'm not going to do it on a call with you, right? If you can get some logs and data and give it directly to some third-line engineers is really, really key, especially for something like storage.
Yeah, and one of the advantages we have with Maya Data, they were very welcome to the idea of growing their product as we grew our platform with their product. So one of the first things we did was we actually gave their development engineering team access to our staging cluster so they could look at actual workload that is being run and used on their software so they could find the issues a little bit more directly. And that actually benefited both sides a lot. We found lots of hard fringe case locking issues, and in a couple of other cases, very obscure differences between how you unmount things, simply because they were able to play with it in that kind of context.
Last question. Without volume snapshots today, how are your customers protecting their stateful PVCs, PVs?
So at the moment, we're kind of leaving it to the customer to kind of work it out. So there are ways of doing it outside of Snapshot, but it's just a lot more old school. So the question was whether we provide read-write many? No. Don't know. It's another layer of complexity, read-write many. that don't know if a lot of people are using in this kind of pod container space, right? So I think the answer has always been from Kubernetes is no, you don't kind of do read-write many, and then you've been pushed down to some storage backends that do allow it, like NFS, and then I'm sure you've all had problems with NFS at some point.
Ask me, I think it's bad practice.
Yes.
I agree, it's bad practice, but the fact is that the customer is asking for legacy preservers.
Yep.
You can always create a NFS share, but I was wondering if you support that.
Yeah, no, I think our advice, so we do a bit of like work at helping customers, is move to something that is more modern. You can obviously now go to things like object storage. So a lot of the problems that you do need read-write many for can be solved with object storage and pushing that up to a kind of S3 type bucket.
Yeah, I totally agree. It's more the shift left when you need to move legacy application or extensively use NFS.
Yeah.
Yeah.
Let's say that I want to migrate from Amazon to you guys, but I need the Graviton machines, right? Because they are cheaper, faster for my personal use. So do you support that architecture or no?
I'm going to say, can we take it afterwards and we'll have a chat about it? I just don't want to make this too much of a Civo kind of thing, right? So happy to have a chat. I'll come up by afterwards and have a chat about it.
Just a quick question. Who's deleted stuff at work right off the PVCs and then just sat there for a minute, tried to figure out how to explain that to everybody else? Okay. I feel better now. Yeah, I deleted the entire prod region once, actually. Me either.
Yeah, this is all right. Any more questions? Okay, maybe we can share what advice would you. Oh, this one? Oh yeah, go ahead.
I am thinking. Okay.
You're fine.
Are you some case using it with, for example, Dataproc or Spark, running as a feral cluster because your cluster starts up very fast and is more cheap than other cloud provider clusters? It could be a very good solution, but to integrate, for example, with Google Cloud and start a Dataproc with your cluster as a feral cluster. Very fast to start, run a model or solve something, and destroy the cluster. Have you another case or a customer doing something like this?
Yeah, so I think one of the other use cases is for CI jobs. So rather than having a cluster that's there always, is the start of your CI job spins up a new cluster and does a full brand new deployment of your application. You run your tests and delete it. So a very similar sort of use case there for those fast spin up times.
Cool. We have like 6 minutes left. Yeah. Okay. What advice would you give to someone wanting to start storing data on K8s?
Ooh. Try to keep the data as close to the processor as you can, would probably be my advice. There's latency domains that escalate rapidly, starting from the CPU through the caches into the disks, and then when you add the network in there, you're just adding more and more application latency that you can never get rid of again.
My advice would be choose something that has been built for cloud-native workloads. So if you're not in a position where you have to migrate legacy workload over, but if you're in a position where you can put in a database that has the ability to do that clustering and failover at kind of cloud scale and design for it, then that would be my advice to move that way.
Don't delete your storage classes either. That's a bad move. Nobody has a good time.
Cool. Any more questions? Yep.
Last one. Do you publish some performance benchmark tests about your storage compared to others?
Soon. So we've been doing some work on it, but yeah, it will be coming out soon.
Very interesting results too.
Cool. Awesome stuff.
Just one last point. Yeah.
Yeah, I was going to ask a question as well.
Oh yeah, go ahead. No, you first.
So I was going to ask about, do you have any insight into like the data services that you're seeing on your clusters, and any particular databases or data services that stand out?
So we don't generally go into customer clusters to see what is going on, right? We're very key on that side of things. So I can only talk about customers that have reached out to us for support. So they've said, I've struggled to get Elasticsearch working, please help. So Elasticsearch comes up a lot still, which kind of surprises me, but that is definitely there. The Grafana products are quite frequently used as well. So that's Loki and Enterprise. I can't remember the metrics one. It's not Cortex, but very, very similar. So those are used, but again, those kind of back off to object storage, right? These are applications that have been designed for this scale out rather than scale up model. So we're seeing a lot of that.
What about like databases? Do you see, obviously not, like you're not seeing people running Postgres, MySQL, or Mongo in there just simply because you don't go snooping, which is, I guess, good to know. But yeah, they're not asking.
I've not had support requests around that. Had, I think, one like a year and a half ago about MySQL, and it was a case of, as I was talking about, they're running one MySQL pod across a cluster that was 20 nodes, all going back to it, and every now and then the MySQL pod restarted, and quote unquote, the cluster went down. Well, we did it. So it's working with them to get them to understand how to run something like MySQL in Kubernetes on a cloud platform.
Sure. Cool.
Awesome. And speaking of future, where do you think folks will be managing data on Kubernetes in let's say the next 3 years?
What's that?
In the next 3 years, I think it's just going to be part of Kubernetes. There's going to be a lot less selection in a few ways because it's going to be a little bit more standardized. Right now, the CSI is essentially in a halfling state where it is not quite done and not quite being done. And I think there's a lot of flux we're going to see. So it'll probably just wind up being another component of Kubernetes nobody thinks about again, just like volume attachments.
I think we're learning a lot about it as well. Running huge clusters in Kubernetes with storage is, I know, something like Google have been doing for ages, but I think we as a community are now starting to push the kind of boundaries about what that looks like. And then I think snapshot support officially, the CSI was only a few versions ago, so still very, very beta. And that's all just going to become run of the mill, and it's going to be like running a container. It's not something you think about.
Awesome. Kai, you can go to the next one. Yeah, that was it. That was all the time we have. Thank you so much. We're running an event next year in Florida, in Tampa. We'll be joined by Steve Wozniak. So, yeah, do check it out. It's called Civo Navigate, civo.com/navigate. And thank you so much. It was a great conversation. I didn't catch your name. The one in gray shirt. Oh, yeah, I'll give you some swag. I have some coupons for the CNCF store. All right. Thank you so much. Thank you.
Good stuff. Just need one of you to choose the for the